Hi, everyone.
Good morning.
Good
people.
morning.
I'm in Europe, so for me it's evening.
It's a little later in the evening, isn't it?
Okay, not so late. It's 7 p.m.
Yeah,
So-
I think it's like 11 p.m. for Amit. So
Yes.
he's even further across the globe from us. So good times.
That's nice. You are completely online. You don't have people in rooms or something.
No on-site. The on-site. We did the on-site for the first 3 years, and then last
Okay.
year COVID hit and we went virtual. I do like on-site. I think they're great. It's probably worse to put it together. I'm not the main person, but it's challenging sometimes. So I kind of like the virtual, but it is kind of nice to bump elbows with everyone as well. But at the same time, we might not have you presenting then because you're like, I ain't flying to LA to do this. So
Yes, that's true.
So we get a larger, a greater diversity of people, and we're up over 1,000 attendees today.
Oh,
So
nice.
it's going to be interesting. We'll see how everything goes.
Yes, I'm also organizing SQL Saturdays, so Data Saturdays in Croatia, and we had one live event 2 years ago, and last year we switched to online, and hopefully that this year we are planning to do it in person, so we will see actually.
Well, best of luck. I know over here people are still a little gun shy about appearing in person.
Brodie, we tried to put together an in-person event in Tampa, and what we ran into is that the venues required a level of insurance that we couldn't afford to buy to cover the liability of having a COVID era event. So it was really the insurance issue that kept us from having an in-person event this year.
Well, and
okay.
the venues have a tendency to, I mean, they're a venue. They need to make something of a profit as well, and we're definitely nonprofit. So
yes,
you have to now turn to your vendors and or your sponsors and say, hi, I need even more money from you in order to hold this event.
yes, that's true.
This does reduce the costing somewhat.
Understand. Yes, it's clear. We also need sponsors for the live event, and this is hard to get them sometimes, and so we will see actually what will happen, but we hope that we will see at least speakers in Croatia, so maybe we will do some kind of hybrid event, like for example have speakers on location and maybe to present online, but it depends because we will wait until September, so then we will decide. Okay, my time is here.
Yep.
So welcome, and thank you for having me as a speaker. I will speak about JSON support in SQL Server. And first, let's see something about me. So I was for many years a developer, and I was programming in ASP.NET C#, and also many other technologies I try in my life, like ASP Vanilla, WinForms, Clarion, Oracle Forms, and etc. So I actually started to use SQL Server for version 2000, and I oriented myself in development and optimization of SQL Server. I worked for more than 9 years for a company called Span, and my current position is senior database developer. I am leading the creation SQL Server user group meetings, and from 2019, I'm organizing SQL Saturday in Croatia. I am also co-founder of Data Weekender conference, and I have my blog about SQL Server, and also I am a Microsoft certified trainer and also Microsoft MVP for my contribution to the community. So we will talk today about JSON, a brief intro about that, and then how to convert SQL data to JSON, also how we can convert JSON documents to SQL format, how to modify JSON data, and I will show you some tips and tricks. This demo will have a lot of demos. So soon, sorry. So JSON, as you probably know, is a JavaScript object notation. It's a language-independent, open standard format for data exchange between application and services. You can store data in JSON format, and JSON format is simple and very popular. It is commonly used in Ajax applications, web services, NoSQL databases. So in simple words, JSON objects are human-readable lists of key value pairs. So JSON actually supports only 3 basic data types: string, numbers, and Boolean values, plus the null for representing null values. All other data types should be casted in one of these. As you can see, there is, for example, no date data type. So dates are represented and processed as strings. A JSON string is, of course, a sequence of Unicode characters surrounded by double quotation marks. Special characters must be escaped, and on the screen you can see the escaping rules for special characters. Here is one representation of customer record in JSON, and on the right side in the XML format. And at the bottom of the screen, you can see the result in the table in SQL Server Management Studio. So compared to XML, JSON format is less verbose and easier to read. JSON object usually contains less data than XML object, and it is more adequate for network transfers. So less data means faster transfer, of course. Okay, we have good internet connection mostly, but it is important if you can save some data. JSON format contains less text than XML format, and data in JSON format are represented by arrays and objects, while, for example, XML is a tree structure. And one good thing about XML is that it can store more complex data types, and it's more robust than JSON. XML can store also additional information, while JSON can store only data. You have another problem. The problem is that, for example, XML is natively supported in SQL. You have the XML data type. You have also indexes about that. And JSON is stored in nvarchar data type. And and of course, you sometimes it use more space because it is nvarchar data type. So maybe you should compress it or something. Do with it. Okay, the main question here is why we would support JSON in SQL Server. And the answer to that question is that JSON, like XML, is a standard and it should be supported. Other vendors support it, for example, Oracle, PostgreSQL, and many others. And some of them, like PostgreSQL, SQL, are very serious and robust. Many different frameworks in these days use JSON, like mentioned before, web services, applications, and etc. So how can we convert SQL to JSON? It's pretty much like creating XML data in SQL Server. You are using the for XML clause. So for JSON, you have the for JSON clause in the select statement. There are two modes supported. So the first one is for JSON auto, and the second one is for JSON path. So the for JSON auto, meaning that the JSON output will be formatted completely automatically, and the for JSON path will be formatted by the query itself. And with using aliases, you can create more complex outputs like nested objects. You also have three additional options. The first one is include null values that you can use actually because normally null values are not mapped to JSON property and they are ignored. Root is similar to the for XML root option, and you can use the root option to add a single top level element to the JSON output. And the third one is the without array wrapper, and you can format the result as a single object. So it will be more clear in the demo. Because of limited data types used in JSON format, SQL Server will convert data types by the rules visible in this table. And data types are not supported by JSON in SQL Server are, of course, geography, geometry, CLR-based user-defined data types. And of course, when you convert JSON to SQL, you must cast the data. Okay, let's jump to the first demo. Okay. So let's try to select gin tonic as a drink for JSON auto, and you will get an error since for JSON auto requires at least one table. So we will actually use a database, and now we will try to select all data from customer records to JSON, and this will fail because the sales customer table contains some geography data, and it is not supported by JSON, but also it's not supported by XML. So for now, we are okay. Second example, we will select only few columns, but still we will get an error. And the reason for that is that this get date doesn't have a column name. So every column should have a name for JSON auto. And now finally, a good example. So I will run this. I will paste this in Visual Studio Code. Okay, this is JSON format. And here you can actually see the JSON interpretation of customer records in SQL Server. And as you can see here, special characters are encoded, and this is pretty much okay. The dates are also encoded, and the date is actually a string. Let's return to SQL Server Management Studio. And okay, this is the same record in tabular data, but don't lose the time for that. You know how it looks in SQL Server. And this is a comparison with XML, for example. So let's see. And here, as you can see, for my document. So this is actually XML representation of the same record, like in JSON. And remember then that I told you that actually JSON is smaller than XML. And here, as you can see, you have 1,500, 499 characters. And in XML, you have actually less. So I was lying to you, not exactly, but for example, if you include elements in the XML, and this format is, for me, actually more readable than this. And in this case, you will notice actually that the XML is larger than the JSON because you have the open and closed tags here. So, okay. So for JSON path is to create more complex output. And notice here that this example now works. We have somebody that's not muted. Can we mute you? Thank you. So JSON for JSON path does not require the table like for JSON Auto, and it's possible actually to create a JSON document without a table. And what is the purpose for JSON path is actually this. Notice here that, for example, the phone number and fax number has aliases like contract, so full stop phone, and contract full stop fax. Now let's go and see this document here. Oh, sorry. What's happened? Oh, my mistake. So you will see actually that this is a more complex document. Now you have the contract, and phone and fax is inside this element. So with this approach, actually you can create more complex JSON documents. And the point is that actually you are using the full stop to create these objects. Notice only that this is impossible to achieve because when you try to do more complex documents, all the fields must be together to be able to achieve this. Okay, let's see the 3 additional options. So this is actually the first example. I will show you this here. So this is a standard normal select. Notice that I didn't use nothing except for JSON Auto. And here you can see that the customer number 2 and customer number 5 don't have the website URL because the website URL is null in these records. So actually null is ignored. And when you use these include null values, you will actually get a document. Let's format it. And notice here, this is the difference. So in this case, when using this include null value, you will get the website URL property in every element of the array, but now it will be null. Okay. Second option is adding a root element. So it's pretty much like XML, as you remember. And now when we format it, you will see that we have the root element customer, and after that you have the array of 5 customers here. So for this, you are using the root customers. Okay, the third option is without array wrapper. So as you can remember here, you have always this array here, but when you are using this without array wrapper, the result will actually be this. So notice that you don't have square brackets here. So you actually don't have the square, the array. We can test it also for 2 records. So notice here, we have 2 elements and we don't have the square bracket. So this is missing here, the closed and the opened at the beginning. Okay, and now we want actually to do a trick and combine together the without array wrapper and the root. So actually, SQL Server, please give me the array without array wrapper and put the root node customers here. And when I try to run this, I will get an error or exception because this is not supported. So it's impossible to combine the without array wrapper with the root together. Okay, this was the first demo. Let's return to the slides a little bit. So, converting JSON to SQL. So for that, you are using OpenJSON, and it is actually an object that can be used like a normal table or view. Depending on the usage, it can return data in 2 possible ways. So default schema and explicit schema. With the default schema, of course, the schema is not specified, and the explicit schema, the schema is user defined and it is specified by the user. Okay, OpenJSON with default schema. So when you don't specify the schema, for return result, the OpenJSON function will return a table with 3 columns: key, value, and type. The key is the name of the JSON property or the index of the JSON element. The value is the value of the property or the index defined by the key column. And the type is the JSON data type of the value. The data type of the column is tiny int, and you can see in this table possible values for this column. Let's jump on the demo. So OpenJSON with default schema. We have a JSON document here, and we will try to select star from OpenJSON, and I'm passing this variable. Notice that the variable must be of data type and varchar, of course. So here we have an exception. Why is that? Because this JSON document is not well formatted, and SQL Server noticed this. So look here, the name is not closed. So we have an error, and SQL Server is trying to guess the location where the error occurs. Okay, the good example. So this JSON document is okay, but we have a small problem because we actually didn't specify the schema of this result set, and we get 3 columns: key, value, and type. So the key is the name of the property. The value itself is this, the value of this property, and the type is a number from 0 to 5, where 0 is null, 1 is string, 2 is int or number, 4 is array, and etc. Let's create a small help function, and let's run it again. So you will actually notice here that actually 1 is string, 2 is int, 0 is null, 3 is boolean, etc. So if you only need values and keys, you can actually use this OpenJSON with default schema. Also, you can do some, select some parts of the JSON document. For example, give me my parents. And you can specify this by using the variable, and the second argument you are using the node that you want to retrieve. So here in the document I have parents. This is an array, and I get two results are only the array. Let's select friend nodes. So actually in my JSON document, I don't have friends, for example. So the result is an empty result set. Okay, but what will happen? We can actually use here the strict comment. So somehow we are forcing SQL that the friend node must be present. And if we try to select this, we will get an exception because the friend node does not exist. Because, for example, if I change the friends with block URL, cannot be opening. Oh, I have an error. Sorry. So, meaning by the strict option, you cannot select non-existing nodes. Okay, let's select favorite drinks node here, and notice here that the result of this is actually an array, and its result is an object. So SQL Server didn't know how to read this. So for him, this is only one object, and it's required to select it differently. Also, this is an example, but now I will show you actually how we can select this, but later. And also when we select in favorite drinks, that's also an array, we will get an object. So these objects are somehow strange because the values are not known. But it will be much intuitive on the second demo after some slides. So OpenJSON with explicit schema. So it's something similar like when reading XML data in SQL Server, we can specify our own schema when reading JSON data. In this case, the function will also return a table, but the output column and their data types can be specified by the user. The schema for the JSON data can be specified using the optional with keyword. Demo. Okay, so this is the same document, and notice now that I'm using the OpenJSON, and after that I open this parenthesis with width, and I specified, so like name is the path to this name, and I told the engine that actually the name is n varchar of 256. After that, I have the block URL, the born, the spouse, the favorite drinks, etc. When I will select this, I will not get any more free columns like before, but I will get as much columns as I did specified here. Also, the complex data types are showed like here. Let's select another time. And now what actually happened? Let's run this together so you will get a better picture of that. I'm using the same, I'm using the same variable. So here notice that favorite drinks and parents are returned, and here are null. Why is that? Because in the first example, I was using SJSON. And in the second one, the SJSON is missing. So actually, SQL Server noticed that the favorite drinks and parents are complex data types. And he said, okay, I don't want to process that. This is unknown for me. And it returns nulls here. But if you actually know your data, then you must specify this as JSON. and you will actually get the result here. Okay. And what actually you can do with this? So it's pretty simple. The first select is like the one before. So we are using favorite things as JSON and parents as JSON. Then we are using the cross apply. It's like a join with OpenJSON again, but now we will use only these favorite drinks. And again, we are specifying the schema of this element. And now when we will run this, we will actually get the name and the drink for every record in here. And this is the way to use this. You have three functions that you can use with JSON. So the first one is Json Value. And the purpose of this function is to extract values from JSON text. The second one is JSON Query, and we will show it later. So what is JSON Value? JSON Value is used to extract a primitive data type value. So only null, string, and number or boolean. Arrays and complex elements will not be selected by JSON Value. One important limitation of the JSON Value function in SQL Server 2016 is that a variable as the second argument, so in the JSON path, is not allowed. SQL Server 2016 supports variable for the second argument. And also, one limitation, if the extracted value is longer than 4,000 characters, the function will return null or the exception. So in lax mode, will return null, and in strict mode, will return an error. We'll show it into the demo. The second function is JSON Query, and it is used only to extract a JSON fragment or to get a complex value type, so arrays and objects. The function also returns a JSON fragment of type nvarchar 4000. The collation of the returned value is the same as the collation of the input expression, and if the value is not an object or an array, of course, in the lax mode, it will return null, and in strict mode, it will return an error. Demo. So notice here, we have our JSON document, and we have this select JSON value, so the variable every time, and then what we want to get. And now we were able actually to extract everything except the non-existing node, because of course it doesn't exist here in the document. And the parents is a complex data type. And as told before, the JSON value is only able to extract basic data types. So only strings, numbers, booleans, etc. So when using JSON value, the complex data types are ignored. And when you will try to use the strict one, you will get an error because the strict actually forces you that this element must be present. Also the limitation, if we have a string with more than 4,000 characters, you will actually get null. But if you are using the strict, you will get an exception. So without strict, you will get null. With using strict, you will get an exception. A JSON query, like told before, it's for extracting complex data types. So for example, in this example, only the favorite colors are returned because only favorite colors are complex, and all other fields here are simple data types. So it's impossible to extract with JSON query simple data types. And if you try, for example, to use the strict approach for this, of course, you will get an exception because SQL Server want to get complex data type. So this, for example, would work only in this way. I will comment here some parts, and when I run this, this will work because the favorite colors is here, and also it is a complex data type. Okay, let's close it. Let's return to the demos. Please, if you can mute yourself. Okay, modifying JSON data. For modifying JSON data, you can use Json Modify, and it allows you to update the value of an existing property, to add a new element of an existing array, to insert a new property and its value. You can also delete a property based on a combination of modes provider, etc. And one important thing, if you want to achieve multiple changes, you must call Json Modify multiple times. It's similar to the, replace. If you want to replace 3 characters of 3 words, in SQL, you must use 3 times replace. So it's for Json Modify is the same. Let's jump on the demo. Okay. So let's try to add, we have a really small JSON document, and I want to add a currently presenting, and I would like actually to get Boolean value. But when I run this, notice in the result set that my result isn't Boolean, and the result is number. So 1, like int. Why is that? SQL Server actually don't know my intentions, and if I pass 1, default is int. So SQL Server thinks, oh, the user wants to send me a number, and that's nice, and I give him a number, and this is okay. But if I want to get Boolean value, I must actually send a Boolean value. So I will actually cast 1 to Boolean, and now when I will create the document, I will get true. So that was my intention first. So you must always know your data and know what you want to achieve. So accordingly, you must use the syntax in this way. Okay, but what will happen if I want to add a new node? So the currently presenting, but with strict. Let's run it. I will get an error. So actually strict always forces us that this property must actually exist. Okay, so what's about this example? I have a meetup list. Notice this is an array. Actually, I want this to be an array, and I want to add in my JSON document a new node called meetups, and I want to send a meetup list. But when I run this, notice what happened here. So this is actually a string. So SQL Server actually escaped special characters, and this is not anymore an array, it is a string value. So you can see that this is a string by this, and this also, and many other things. And what about adding array? So if you want actually to add an array, you must use the JSON query. So, okay, modify the JSON data, add a new node meetups, and put inside the meetup list that actually this is a JSON query. Let's run it. And now here is the difference. Notice that now the meetups is exactly an array with 2 elements, and it's not anymore a string. Okay, How can we remove JSON property? It's simple. We have a large JSON document. We have favorite rings. That's pretty large. And we will remove it by passing null. So favorite rings replaced by null. Let's run it. And the result is what we wanted to get. So we have everything like before, but favorite rings is missing. So it's totally ignored. Okay. Also, let's try to remove something. We have here the meetup list. Of course, we have 2 meetups, 1, 2, and I want to replace the first one with null. Let's try it. So actually, the first one is replaced with null. But maybe this wasn't my intention. Maybe I wanted to remove the element completely. And how I can do this? It's not so simple. So if I want to remove the whole element, I must actually pass a completely new value for this. So I am in the meetups, I am replacing this by this. And after that, I will not get the null like before, and I will get only one element in my meetup list. So this is not simple. How I can update one element. So I have meetups, first and second, and I want actually to replace the first one with something about new SQL Server functions. And this is logical. It will work. So I don't have any more new SQL Server 2016-17 functions. I have something about new SQL functions like seen here. Okay. Let's try to change the first element in the non-existing lectures mode. Guess what will happen? It will happen nothing. So in the original document, there wasn't any lectures. So SQL Server was unable to replace the first element of this. So the result is completely identical to the input one. Okay. One usage is also to use this append here. So let's see. I have meetups. I have 2 meetups here, and I want to append the third element. So in this way, you can actually append third element. So the resulting array has 3 values. And what will happen if we try to append something to the non-existing lectures node? Let's try to run it. And guess what? SQL Server was intelligent. Here, SQL Server actually created a new node called lectures and created put one array in this. And this is actually great. But also we can use the strict one, and then we will get an error. So the strict always forces us to have this value, what we want to change. Okay, let's see this example. So remember before, maybe you can remember before that we were also replacing the favorite rings with null. And this element was completely removed, something like this. But let's try to see what will happen if we use the strict and null combination. Notice that the result have favorite rings is here, but only this is removed and it's converted to null. So this is a great way, actually, if you want to empty just one node and one element from your JSON document. And last one is, as I told you, for if you want multiple changes in your JSON document, so you must call multiple times. It's similar to the replace. So if I want to make 2 changes to my JSON document, I must call the Json Modify twice. So multiple changes, multiple calls, and this is okay. Let's return to the slides. I didn't look. Are there maybe some questions, or we can do questions at the end maybe? How do you like? So the third question, the third function is JSON, and this function actually checks if the input string is a valid JSON data. It returns 3 states. 1 for yes, 0 for no, and null for null. But notice and take care that each JSON doesn't check for the uniqueness of keys at the same level. So at the right part of the screen, you can see a JSON document that actually is valid. So each JSON function would return 1 for this. And you can think by yourself if this is okay or not. And some tips and tricks. For example, you have the option to import JSON from a file on hard drive. This is pretty cool for some big batch imports. Also, we will talk a little bit about indexing JSON data, because JSON is represented by n varchar data type. So we must actually find a way sometimes to do it better and faster. And also I will show you 2 or 3 nice examples of JSON. Cool. So this is the first is demo based with isJSON function. So notice null is returned like null. The invalid JSON document is returned by 0, and the valid is returned by 1. So this is valid, but this one is valid, but I'm not sure if this is actually valid or not. So maybe if you are using JSON all the time, you can tell me what do you think about the validity of this document. Okay, JSON can be used, for example, in many ways. One of the ways is, for example, if you have a table, so I will create a new test table that's called test user settings. Imagine that I want to store user settings in this table. The value can be null, for example, if the user doesn't have settings. But for example, I know that the application team told me that actually the settings are a JSON document, and I want actually to check and insert records only if the settings are actually JSON. So I will create app settings that's actually nullable, but I will also create a constraint check that the app settings must be 1 when running each JSON. Okay, let's create the table and let's try to insert 3 records. And now I will select the 3 records. Notice that only 2 records are stored here. Why? Because the first one is null, and this is okay because I actually specify the user doesn't have to have settings. The second one isn't inserted because it is not a valid JSON document. It's missing. And the third one actually is inserted because it is a valid JSON document. Okay, I have on my hard drive a JSON document that actually can be very large. And I really did some imports of about JSON files of 100 megabytes and more. And this is actually a way to import JSON documents from hard drive. And it's sometimes it is really nice for some batch inserts. Okay, let's talk about indexing JSON data. We will use the one test database. I will create a test table. I will insert some test rows. Also, I will run statistics turn on. And now let's find every record that the postal city name is Idaho City. And I get one record here. Let's see at the execution plan. We have a clustered in scan. So meaning the SQL actually scanned the whole table for this. And you see here, we have 75 logical reads. And even this table is not so large, of course. And we take about 40 milliseconds for this. So imagine that actually we have 1 gigabyte of data, and this query would last forever. So one approach to solve this is to create a computed column. So I'm altering my table and adding computed column. I will create an index on the computed column, and I will repeat my select. Let's look at the execution plan. So now we have actually the index scan on this index that we are using. And now we have only 7 logical reads. And actually the query is faster, but right now on this execution wasn't, because still we have some time to adopt. Okay, let's drop it. Second example of using this, of optimizing JSON documents, is full text catalogs and full text indexes. So actually I created full text catalog, and I created an index on customer data. And I will actually look all records that are like Idaho City. And when you look at the execution plan, so maybe my catalog is still building. Okay, now it's finished. So you will see actually that this is a full text match. So actually the full text catalog was used for this. And we have a cluster index seek, not anymore scan. And if we look at the logical reads, we will get only 2. So it's better performing. Let's clean this. One really cool example of using JSON is the following one. Imagine that you have 2 rows in one table. The table has, like in this example, 86 columns. And your boss tell you, please compare these 2 tables or rows by column values and give me only columns that are different by value. So what would you do in this case? So you will really have problems, because to compare 86 columns one by one values, it's really a big job in normal queries. But with using JSON and this syntax here, you can do it fast. So this is the SIS database, as you know, for this table. It has 86 columns. And this is, the first one is master and the second one is model. And only these 9 rows are different. So this query actually in very fast will detect the differences between 2 rows in tables. So this 9 out of 86 columns are different, and this demo is really cool. So JSON is really cool sometimes when you use it. You can, of course, use it for processing comma-separated list of values, but you must fake JSON array. So you must actually add this at the beginning and the end. But when you are doing this stuff, you must take care that, for example, the document must really be be well formatted. So, for example, this is an error because JSON array cannot not have an empty element here. Okay, and another really cool usage of this JSON, for me at least, is, for example, when I want to make a sync between two databases or two SQL servers. I have, for example, a read-only database for reporting, and I have an active database. And I want actually to have a job for every 15 minutes to insert only changed rows and new or changed rows, for example. So what I'm doing usually, and you don't have a replication and whatever sometimes, so you have a custom solution for that. So we can solve this by actually selecting all the columns of one row in JSON and then compute a hash for this row. So let me show you how it looks in the demo. So actually these columns here, one row, this is the hashed JSON result of this row. Here is the hashed row result of this row. And then you can actually really fast do some comparison and know what records are changed in, for example, read-only database and in the main database by only comparing this hash here. So if the hash is different, then the record has been changed. And you can fastly update these records. So this is the last demo. Thank you very much. Please feel free to contact me if you have questions later. And also, I think we have 5 more minutes. And I want to know if you have right now some questions for me.
Okay, if anyone has any questions, please, by all means, go ahead and drop them in the chat.
I hope that you enjoyed this session.
Okay.
Seems like no questions.
You're dropping a lot of knowledge, Damir. It's sometimes it's a challenge to pull it all together and make sure it. Can you go back over the where you were comparing two databases for changes?
Yes. Meaning the hash or 2 rows?
The 2 rows.
Oh, this.
And I mean, this is a great example, but is there, would you use this to compare data sets or anything like that?
No, I would use this only for to find different columns in 2 rows, and this is actually the only usage that I would use this. And when comparing whole 2 rows, then I would jump to this, like shown before, with hash values. So hash value will tell me that the whole record set is changed, meaning the whole row. And this approach is only to find different values in 2 columns. So one column of 2 rows, okay?
All right. We have another question. Ted would like to know where we can get the demo scripts.
Oh, that's a really great question. That's a really great question. I can try to share it right now and to give you the shareable link.
You might even be able to drop the files directly into the chat.
Yes. Yes. Just a second.
Or if you prefer to point to a GitHub, that's cool too. Whichever one.
Oh, I am not sure that actually I did upload it to GitHub now, so it will be actually faster to share it here. Oh, but I cannot share a file here in the chat.
You can't? Okay.
No, I can't for some reason.
Okay.
I can for some reason, so I will give you a link. Just a second, sorry. Okay, share. Here you go. Please, if you can confirm me that you can access this. Hello?
OneDrive is opening up, and yep, everything is coming up over here.
Okay, nice. I will leave this. So
And we're getting confirmation from others that they're able to download the script too.
Okay, nice.
Well, thank you very much, sir. And I'm going to steal the show again here.
So thank you one more time for having me as a speaker, of course. And it was really a pleasure. I hope that you enjoyed it.
Yes, thank you very much. Json was never one of my strong suits.
Okay.
And I really liked the subcategorization, you know, the contact.phones, contact.fax piece. I hadn't even realized that that was a functionality that was available in JSON.
Mm-hmm. So,
okay.
And of course, thanks to the sponsors.
Oh, yes, very much so. Without the sponsors, we really couldn't put this on.
Yep. Have a great day.
Thank you, Damir. Have a great evening.
Yes, enjoy the rest of this wonderful, wonderful event. And thank you very much for organizing it.
Oh, you're very welcome. And thank you for presenting. We couldn't do this stuff without all the great content coming from all of our speakers.
Thank you very much. Bye.
Bye-bye.